Okay, so this is my second take on this recording. Um, let's see if I can actually manage to save this one. Okay, so number 11, somebody asked for this in the chat. The sum of minus 3 plus minus 12 plus blah, 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 up to 100, sorry, 12,288. Well, let's see. We're going to use this formula. S sub n is equal to a sub 1 times 1 minus r to the n all over 1 minus r. And this is the formula for a geometric sequence, for the partial sum of a geometric sequence. I'm going to plug in the numbers that we know, and then you'll see a problem, and we'll resolve that problem. So S sub n here is going to be, a sub 1 is the first term, so that's minus 3 is the first term. What's the common ratio? Well, the common ratio is 4. I hope that you can see that. You're multiplying by 4. So this is 1 minus 4 to the n all over 1 minus 4. Okay. Well, now the problem is I don't know what value of n I should plug in. N is the number of terms, but what is the number of terms? Well, in order to figure that out, I need to, first I'm going to give the general formula for this sequence. A sub n, I know the generic formula for a geometric sequence is a sub n equals a sub 1 times r to the n minus 1. And that's equal to minus 3 times, let's see, 4 to the n minus 1 in this case. And what's my a sub n? My last term is going to be minus 12,288. That's equal to minus 3 times 4 to the n minus 1. Okay. I'm going to divide by minus 3 here. And what I get is, let me get out my calculator. That's 4,096. Good. So what is the, so 4,096 is equal to 4 to the n minus 1. What is n equal to? Well, if you use logarithms, or if you just, think this out, you get that n minus 1 is equal to 6. And so this tells me that n is equal to 7. And let me write that here. Let me shrink this down, and I'll write that over here. So n is equal to, so n minus 1 equals 6. And that tells me that n is equal to 7. So my S sub n is 7. Okay, and so you can plug this into your calculator, you can do some algebra to simplify this. I don't really care, so long as you use the right formula, so long as you write the formula that you're using, and so long as you show your work for how you found the value of n. I don't really care if you plug the numbers in correctly into your calculator. If I see this, finally, if I see this as well, you've probably gotten the full marks already. You are supposed to plug it into your calculator, but if you mess up, don't worry too much about it. You'll still get the full marks. Okay, next. Find this sum, the sum from n equals 31 to 100 of 6n. Okay, so in order to do this question, we need to use the formula for the nth partial sum of an arithmetic sequence. This is an arithmetic sequence because you're adding by 6 each time. If you were to see this, the 50th term here would be 300, and then the 51st term would be 306, and so on. So you're just adding by 6 each time. This is an arithmetic sequence. Okay, so S sub n is n times a sub 1 plus a sub n all over 2. Okay, fine. Now the question is, first of all, well, okay, let me plug in the numbers that we already know. A sub 1 is going to be 6 times 31. That's the first term in this sequence. The first thing that you plug into here is 31. A sub n is going to be, the last term is going to be 6 times 100. That doesn't mean that there are 100 terms in this sequence, right? You're missing the first 1, 2, 3, 4, 5, 6, up to 30 elements of this sequence. So we have to figure out what is n equal to. And n is actually going to be equal to 70. Why 70? Well, okay, let me try to explain it this way. From 1 to 100, from 1 to 100, there are 100 numbers. Okay. From 31 to 100, there are actually 70 numbers, right? You might be tempted to say, oh, okay, I'm going to do 100 minus 31 to get 69, but that's not right. It wouldn't be right to do, 100 minus 1 equals 99 numbers. That wouldn't be right. You have to do 100 minus 1 plus 1. You have to do 100 minus 31 plus 1, and this is 70, and this is 100. So you get the right answer in both cases if you do it this way. Okay, so in this case, my n is actually 100 minus 31 plus 1, which is 70. So the answer here will be 70 times a sub 1 is 6 times 31. Let me plug this into the calculator here. 186. And 6 times 100 is 600. So this is 186 plus 600 all over 2. And that's going to be the answer. You'd plug that into your calculator, you'd get the right answer. I don't really care so much about what the answer is, so I'm not going to plug it in. But if you were to write both this and basically fill out this information, and then you get this expression here, you basically get full marks. Okay. All right, next question. Find a formula for the general term a sub n. Okay, well, people have trouble with these kinds of questions. I'll try to explain why. So C sub n, let's say that a general element of the sequence is C sub n. It's going to be composed of a sub n over b sub n. This is the technique we're going to use. So up here, you see we're adding by 3s. At the top, we're adding by 3. And on the bottom, we're multiplying by 4s each time. So this sequence is actually neither geometric nor arithmetic, but it's composed of an arithmetic over a geometric sequence. Okay, so a sub n is going to be, remember, the generic formula for an arithmetic sequence is a sub 1 plus d times n minus 1, where d is the common difference. So that means a sub n here is going to be, what's the first element? 12. What's the common difference? 3. I'm adding by 3 each time, times n minus 1. And that's going to be the first element. Sorry, that's going to be the numerator. That's going to be the numerator. What's b sub n? B sub n is geometric. Okay. Whereas a sub n was arithmetic. Okay. So b sub n is geometric. That means that b sub n will be of the form b sub 1 times r to the n minus 1. Okay, good. That means that, in this case, b sub n will be equal to, let's see, what's b sub 1? 4 times, common ratio is 4 to the n minus 1. And you just plug that in. And this is it. You could simplify the top and the bottom, but you don't really have to. This will get you full marks on the exam.